Hello, hello everybody. So today I'm going to teach you about job sequencing. As everyone has requested that they want to learn optimization techniques once again. So what is job sequencing all about? Job sequencing is the problem of determining the sequence in which a number of jobs should be performed on different machines in order to make effective use of available facilities and achieve greater output. And if we are having 5 to 7 jobs and we have a few people whom we can assign such jobs, obviously we would like our jobs to get done effectively and on time. So but before solving this job sequencing problem, there are a few assumptions which we have to take into consideration. The first assumption is the processing time on each job is known. You would be given 2 machines, you would be given few jobs, or maybe 3 machines, maybe 5 machines, maybe 10 machines. The processing time would be known for each and every job. No machine may process more than one job simultaneously. That means one machine has to process one job at a time. The time taken by each job in changing over from one machine to another is negligible. That means when we will switch one job after completing it on one machine and then changing it to the second machine, its processing time is negligible. Each job once started on a machine is to be performed up to completion on that machine. When we will assign any job to any machine, we cannot stop that job. We have to make sure that it gets executed completely so that we can give it to the another machine. No job is to be given priority. A job starts on machine as soon as the job or the machine both are idle. If there is any machine which is idle and there is job which is available to get executed on machine, we can assign that job to the machine. Now, for job sequencing problem, there are two problems which we have to solve using job sequencing according to our syllabus. The first problem is processing of n jobs through 2 machines, and the second problem is processing of n jobs through 3 machines. That means how can we process n jobs on 2 machines, and what should be their sequence, and how can we find the total time? And what is the processing time of n jobs through 3 machines. So today we will start with the first problem, that is processing of n jobs through 2 machines. Let us take an example and we will solve this. The questions like this: find the sequence that will minimize the total time required to complete the following task on 2 machines. Processing time is given below for each task on each machine. Find the sequence and the total time. That means we have to find two things. We have to find the sequence of jobs which we can assign to 2 machines, that's machine A and machine B, and after that we have to find the total time. How much time it took us to execute 5 jobs on these 2 machines. So the first thing is we have to find the sequence so that we can assign the jobs on 2 machines. So let us start solving the question. So the first thing is we have to find the sequence. Okay, so find the sequence. So for that purpose we have 5 jobs over here. So we will make an array of 5 cells: 1 2 3 4 and 5. 1 2 3 4 and 5. So we know that this is the right side of the array and this is the left side of the array. Okay, now how to find the sequence? There is a procedure for that. And what is that? So in order to find the sequence, what we have to do is we have to look at this table and we have to find the minimum processing time out of all these. These are the processing times. This means the job number 1, if I want to execute it on machine A, it would take me 6 hours of time, or maybe 6 minutes or 6 seconds. That's not mentioned in the question. If it is mentioned, so it would be like that. So we will assume here that it is 6 hours. Okay, processing time is in hours. Okay, processing time is in hours. Fine. So out of all these processing times, the minimum processing time is 2, and this 2 belongs to machine A. It says if the minimum processing time belongs to machine A, write that on the left side of the array. So job number 2, we will write it in left side of the array, and this would get, the row would get cancelled out because we managed job number 2 to get executed on the first place. Now out of all the processing times, again we have to find the minimum time, and that is 3. But job number 3 belongs to machine B. I mean, not job number 3, job number 1 belongs to machine B, and it takes 3 hours of processing time. Right? If the minimum processing time belongs to machine B, write that on the right side of the array. So job number 1 would get executed over here. Delete the whole row. Now, out of all the processing times, the minimum processing time is of job number 4, and this would get executed on machine A. So write job number 4 on the left side of the array and delete the row, and follow the same procedure on these two rows. 5 is the minimum processing time, and this belongs to machine B. So job number 5 would get executed over here. Now we are left with only job number 3. You can place it over here. So this is how we find the sequence. Now we've got the sequence. Now we have to find the total time. For that, what we have to do is we have to follow a procedure. So how to find the total time? So that means this is a sequence which we have to follow in order to give these jobs, in order to assign these jobs on two machines. That means the first job which would get executed on these two machines is 2, job number 2, then 4, then 3, then 5, and then 1. So let us design or create a table of machine A and of machine B, where we can write the in time and the out time of both the machines. The in time and out time would represent when job number 1 was assigned, or at which hour it was assigned to machine A, and when it gets completed on the same machine, and like that. Now we know the sequence. The first job which would get executed is 2, then 4, then 3, then 5, and the lastly 1. Okay. When we have to start assigning the jobs, the initial idle time would be taken as 0. Both machines and all the jobs are idle, so we can assign the job simultaneously. And please remember always, we always have to follow the procedure as it is mentioned in the question. Like, first it comes job A, then it comes job B. So we have to first assign each job to machine A, then to machine B. We cannot do the reverse. We cannot first assign it to machine B, then to A. That's not possible. Okay, so the initial idle time would be taken as 0. Okay, that means we have to assign job 2 to machine A. Okay, and we know, and its idle time is taken as 0 because both are treated as idle, so we can assign the job. They don't have to wait for any hour. They don't have to even wait for a second. And we know job number 2 on machine A would take how many hours? 2 hours of processing, as it's written here. So it would get executed for 2 hours, and it would take 2 hours of time in order to get executed on machine A, and it gets completed after 2 hours. When job number 2 gets executed on machine A after 2 hours, then it would be given on machine B. As I already discussed with the assumptions, we cannot perform 2 jobs simultaneously on 2 machines. No, that is not possible. We have to follow the sequence. Sequentially, we have to execute them. Firstly, job number 2 would get executed on machine B after 2 hours of time, because it is taking 2 hours of processing time to get executed on machine B. That means machine B has to wait for 2 hours in order to execute job number 2 on itself on machine B. And we know job number 2 takes 7 hours of processing time in order to get executed. That means if I would assign job number 2 in this at the second hour, and it takes 7 hours of processing, so it means when it get executed, it means 7 plus 2, it is 9. That means it would get completely executed after 9 hours of time. Okay, Now, as you can see, while I am assigning job number 2 to machine B, here machine A and job number 4 both are idle. I can assign job number 4 to job A, to machine A, while job number 2 is getting executed on machine B. So this would get executed, completely executed at the second hour. That means at the second hour, fourth job would be given to machine A, and clearly here we can see job number 4 would take 4 hours of processing time in order to get executed on machine A. So 4 plus 2 is 6, so it would take 6 hours of time to get executed on it. Now machine, we have to wait, job number 4 has to wait for machine B in order to get completely executed job by in order to get job number 2 completely executed on machine B. So job number 4 won't get it's job machine B's idle time is basically the time when it gets executed. Job number 4 would get executed at 6th hour, and job number 2 on machine B would get executed completely after 9th hour. That means machine B has to wait when that means job number 4 has to wait until job machine B completes job number 2. So it would get started at the 9th hour, and we clearly see job number 4 would take 9 hours of processing in order to get executed on machine B. So 9 plus 9 is equal to 18. So this would get executed on 18. So this, and similarly we can follow the rest of the things. This would get started at 6. It takes 10 hours of processing on machine A, so this would get completed at 16. Machine B has to wait up till this 18, so it has to start job number 3 at the 18th hour, and job number 3 would take 8 hours of processing on machine B. So 18 plus 8 would be 26 hours of processing. Then this has to start at 16th hour, and job number 5 would take 11 hours of processing on A. So it would get executed completely on machine A at 27th hour. Now see, look here. Here machine B is idle at 26th hour. It is waiting for job 5, which takes 1 hour more in order to get completed on machine A. So job number B has to wait for 1 more hour. That means we can start it at the 27th hour of processing. So job number 5 would take 5 hours of time in order to get executed on machine B. So 27 plus 5 would be 32 hours of processing in on machine B. Now here it would get started at 27, and job number 1 clearly takes 6 hours of processing on machine A. So this will be 33 hours of processing. It would get completed. Here again 32 and 33, we have to start it at 33 because this has to wait until job number 1 would get executed completely on machine A, and job number 1 takes 3 hours of processing on machine B. So it will be 36 over here. So we can say the total, therefore the total time to execute all these jobs is 36 hours. So this is the total time, and this is the sequence which we have to follow. So this was all about job sequencing, and the first problem was processing of n jobs through 2 machines, which we did today. I hope it was sufficient and you can do it furthermore. I would give you one example which you can take as an home assignment, and it would be like this. You are having 2 jobs, you are having 1 2 3 4 5 6 jobs, job A, B, C, D, E and F. Say you have 2 machines, obviously A, B. So these are the processing times: 21 12, 32 14, 15 61, 7 8, 9 10, 71 12, and you have to find the sequence and the total time. Thank you.